Welcome to Ask and Learn.
We want to produce graphs of f of x is equal to 6 times sine of x plus cotangent of x on the interval negative pi to pi that reveal all important aspects of the curve, and in particular we want to use graphs of the first and second derivatives to estimate the intervals where the function is increasing, decreasing, look for any extreme values, intervals concavity, as well as points of inflection. So first I just went ahead and plugged in f into my graphing calculator, and when I did that I ended up getting this first graph here on the left. And I mean, that looks pretty good, so maybe we really don't need to use calculus to actually find a better viewing rectangle, but let's just go ahead and see. So I also went ahead and found the first and second derivatives and plotted those as well, and then estimated what these x-intercepts are going to be. And I chose my viewing windows. Well, in this case, since it's just negative pi to pi, we really don't need to choose anything. But normally when you do this, you just want to make sure whatever your values are, we always hit all the x-intercepts at least, because those are the important pieces for these graphs. Now, one thing we might need to kind of think about is this function is actually not defined at negative pi, 0, or pi. So in the original function, let me just go ahead and draw. We have vertical asymptotes at x is equal to 0, and x is equal to pi, and negative pi. And likewise, for our derivatives, we will have vertical asymptotes at those points too. So we don't really have to worry about the endpoints. But for our intervals of where we're figuring out if it's concave up or concave down, we will care about those vertical asymptotes. All right, so x is equal to 0. All right, so now let's go ahead and find our intervals where it's increasing, decreasing first. So remember, a function is increasing when f prime of x is strictly larger than 0. So it looks like it starts to become positive at negative 1.398, and then it's going to stay positive until negative 0.444. Then it's positive again, 0.444 to 1.398. Now to find where it's decreasing, we want to find where f prime is strictly less than 0. So this is going to be from negative pi, because that's our endpoint, to negative 1.398, union with negative 0.444. Now to 0, because remember that's where our vertical asymptote is going to be at, union, then 0 to 0.444, and then it's going to be 1.3982 pi being our other interval, or our other endpoint on this interval. Now we can go ahead and say whether these critical values are going to be maxes or mins. So our first point here, we're decreasing into it because the derivative is negative to the left, and it's increasing after, so we will have a local min at that point there. Our next value, we're increasing into it and then decreasing after, so that would tell us this is a local max. Let me go ahead and write these above it like that. Then the next one, so since we have that vertical asymptote, let's go ahead and just start over. So it's decreasing into it and then increasing after. So this here is going to be a min. And our last point, it's increasing into it and then decreasing after. So this will be a local max. All right, now that we have that, we can go ahead and look for where our function is concave up and concave down. So remember, it will be concave up when f double prime is strictly larger than 0. So this is going to be, so we're going to start from negative pi, and we're going to go until we hit our first intercept, which is negative 0.774. And then it starts to be positive on the right side of our vertical asymptote. So it'll be 0 to 0.774. Now for where it's concave down, we just look for where f double prime is strictly less than 0. And that will just be the remainder of the interval. So negative 0.774 to 0, unioned with 0.774 to pi. And now to see if these are points of inflection, remember what we want to check is to see if we have change in concavity around both of our x-intercepts. So to the left, it's concave up, and to the right, it's concave down. So that means we have a point of inflection. And for our other one, it is concave up and then concave down again. So also a point of inflection. So we know, at least for what x values, our maxes and mins occur at, as well as our inflection points. So I went ahead and plotted those values. So these first four are our max and mins. Max, mins, or at least I should say local max and mins. These next values are our inflection points. And these last two are our endpoints. But in this case, the function is not defined at negative pi or pi. All right. Now the next thing, once we have all those points, it is to decide what our viewing window should be. So we already know our x viewing window should be negative pi to pi, so we didn't really have to decide anything there. And we only need to decide on what our window for y should be. So what I did was I just went through these values and looked for the largest and the smallest one. So our smallest value is about -6 here. So I needed to go something slightly under that. And our largest value was +6. So we needed to go slightly larger than that one as well. And so we can see those 6 points for the local max min and our inflection points are all listed as those dots on our graph. And we can see now that we did actually miss some information from that first graph where we just plugged it directly in to it.